So spatial SQL is no different than your standard SQL, right? You write it, and many times we'll use a lot of the functions you use in standard SQL. What differentiates it is two data types, really. One is a geometry and one is a geography. How it's used in GIS today is very interesting. I see it from maintaining a central enterprise database of geospatial data. People use it to maintain and manipulate geometries and create geometries programmatically. I think the most emergent space is, geospatial data engineering. SQL is one of the core toolkits of data engineers, and I see more and more it being used, from the data engineering space or managing large amounts of geospatial data.
Hello, welcome to another episode of the Geospatial Africa podcast. Today's episode, I'll be talking to Matt Forrest about Spatial SQL. So before we get started, let's just get diving. Hi, Matt. Thank you for agreeing to do this podcast with me. It's really something I was really looking forward to, and I think it's going to be interesting both for me and the listeners as well. So welcome to the podcast, Matt.
Yeah, thank you for having me. Excited to be here.
Yeah, so before we start, talking about Spatial SQL, could you tell us a little about yourself, how you got into geospatial, and what you're currently working on?
Yeah, so I got into geospatial and GIS when I was at college. So I went to the University of Wisconsin in Madison, Wisconsin, and sort of by accident ended up in the geography program. I was not sure what I wanted to major in, and a advisor suggested I check out geography, and I did, and I liked it. And so I did a lot of different things, but ended up really enjoying kind of the analytical and also the cartographic side of it. So, I had a pretty traditional, geospatial or GIS, education. After I graduated, after about 2 years, I moved to New York City and met a lot of folks out here that were really working on open source and different tools. And there was a lot happening at the time, where different companies were being formed and products were being built, like Mapbox, and PostGIS was really starting to take off, and ultimately Carto, where I met Javier de la Torre, who was one of the founders. I started using Carto, and then eventually just joined the company, which is where I've been for just over 7 years. And what I do there today is I head up our solutions engineering team. So what that sort of looks like is really just using our tools, working with customers, and ultimately kind of working on a lot of spatial analytics day in and day out. So I get to see a lot of different things and work on many different problems, which is the really fun part. And I get to do kind of what I enjoy. So in that sense, I count myself pretty lucky. So
awesome. I think that's really a great background there, coming from, from school, doing geography, and then, being able to work with these amazing companies to build solutions that people are using. I actually wanted to talk about, what your role as a VP solutions is, but I think you already touched on that, and I think that's really great. And a lot of people don't get to enjoy what they do, but I think it's, like you said, you're really, lucky to be able to actually do what you love every day.
Yeah, exactly. I think for me, I get to go to work, I get to enjoy what I do, and I get to actually use the skills, many of which I learn. I've been able to learn a lot, but there's also a lot of new things that I continue to learn every day. So it keeps you on your toes. And I think that's one of the parts I love the most, is just constantly learning and trying new things, and then, engaging with the really amazing global community that, talks about and interacts around geospatial. It's really fun.
Yeah, I agree, and I think for that could be attested to the fact that you're always active on LinkedIn. You're always sharing things you learn or things you found, and I think that's really interesting to see. And I'm sure a lot of people who've seen your posts are also learning a lot, because you're sharing what you've learned and what you know. So I think that's really brilliant.
Yeah. I appreciate it.
Thank you so much for that, actually.
Yeah, of course. It really started out of just that. Like I was able to learn a lot from people around me, and just kind of wanted to, give it back a little bit. And it's been pretty crazy, the response. So it's been fun, and I'm just glad it's useful. So.
Yeah, sure. So one of the things that you talk about quite a lot is Spatial SQL. right? So that's what this podcast is really about, just to talk about and try and see how we can get a lot of people on board, to want to understand more. So of course, before we talk about special SQL, right, there's always the SQL. So what is SQL, and why is it why is SQL important when working with data? So we're talking about generally now SQL as the backbone of special.
So SQL, it generally shows up as the acronym SQL, which stands for Structured Query Language. And it was developed, I think, in the 70s, and as primarily a way to, query and retrieve data. It's evolved quite a lot since then, into pretty much a standard around using and interacting with data. There's a brief period, maybe in the 2010s, when there was this thing called NoSQL, which is sort of not only SQL or NoSQL, but it was a sort of a non-standard tabular database. It was nested data that looks more like JSON. And it was good at handling sort of large data to a certain degree, but SQL kind of came roaring back when cloud companies started to develop data warehouses, which we'll talk a little bit about. But it's very important because it allows you a very structured, readable way to interact and query data. You can also perform common, sort of CRUD operations. So your inserts, updates, deletes, things like that, with a database. So you can manage lots of different data with that. And it gives, like I said, it gives you a very controlled way to actually interact with that data. So that's sort of what SQL as a whole is. It's, like I said, it's become very popular. And when you look at, top skills that, employers are looking for, especially in analytics and now more so in geospatial analytics, SQL, tends to pop up and be right up there with Python or any other toolkit that you might see. So I think it's going to become more and more a core part of, the geospatial toolkit as things evolve over time.
Yeah, I totally agree with that, because we're seeing, like you mentioned, SQL is also a rising tool that is being used alongside other geospatial tools. So let's now dive into talking about special SQL, because you've done justice to explaining what SQL is and why it's important when working with data. So you talk a lot about modern GIS, right? So there was a podcast you had with Daniel, where you talked about modern GIS, and you write about it a lot, So Special SQL is actually one of the toolbox in modern GIS, right, alongside Python and other tools. So what is Special SQL, and could you maybe provide an overview of what it is and how it's being used in GIS, which is special?
Yeah, so Spatial SQL is no different than your standard SQL, right? You write it, and many times we'll use a lot of the functions you use in standard SQL. What differentiates it is two data types, really. One is a geometry and one is a geography. So a geometry is sort of your projected data, and your geography is your data, on the round surface of the Earth. So those two data types go alongside every other data type you have, things like strings, numbers, floats, booleans, dates, arrays, so on and so forth. So you just have another data type that you work with. Now, of course, you need different functions to work with that data, just as you would have different functions for those other data types. And that has been standardized by OGC, I think, since 2003. So there's a standard for the spatial SQL naming conventions and formats. And you can go ahead and look it up, but effectively any function, or the majority of them, will start with the ST underscore, which stands for spatial type. So that's why you see all the functions ST intersects or ST as text. You see those are spatial SQL, and that's the standardized language that they use. Now, that can vary bit by bit if there's a specialized function in one language versus another. But for the most part, there's a core set that are standardized across all of them. And Spatial SQL allows you to do everything that you would do in a database, but with geographic data. A simple example is, in a database, you could, let's say you have a data set of records, and there's kind of a time component of it, and you want to aggregate, a numeric value, let's say, total sales month over month, right? So you can group it by the date, pull out the month from that date and say group it by that. Same type of thing with your geospatial data, but what we might more commonly know as a union, you can do in union geometries together with a common value. So if you want to grab all the counties within a US state and aggregate them that way in a spatial union, you can do that with a different function called stunion. So there's lots of different ways to do that and lots of functions to actually work with geospatial data. How it's used in GIS today, I think is very interesting. I see it from maintaining a central enterprise database of geospatial data. People use it to maintain and manipulate geometries and create geometries programmatically. People use it for analytics. People use it for transactional, data that's coming from maybe a web application or somewhere else. All the way up to big data systems to, manage large amounts of data in a data warehouse or something like that. I think the most emergent space is, geospatial data engineering. SQL is one of the core toolkits of data engineers, and I see more and more it being used, from the data engineering space or managing large amounts of geospatial data.
All right, great. Thank you so much for that. I think you've touched on a lot of subject there. You talked about how SQL is a little bit different from Special SQL. So Special SQL is like an extension of SQL to support geographic data types, right? And I think that's really great. And you talked about the different things that could be done with Special SQL, and I think it's a lot to unpack, right? And someone who's listening might who wants to dive into learning might feel like, it's overwhelming. So I mean, you've worked with Special SQL, so what do you think are the common challenges or pitfalls that users might encounter when working with Special SQL?
Yeah, there's a few. I mean, for me, the first one is getting started setting up a database, right? Unless you already have access to a database and an interface to interact with that database, it can be pretty tricky. If you've never worked with the command line, you go to a website and that's kind of some of the first things you do. It's gotten a lot easier, I would say, but that's historically one of the first kind of roadblocks. More and more PostGIS has sort of user interface installers that you can use. So actually getting it on your computer is quite easy. There's more cloud-based tools that allow you to do this for free to a certain point or for very inexpensive. But that's one sort of pitfall is getting it up and running on your computer. The second is importing data, right? In a traditional GIS setup, you just have your files and you open them in your desktop toolkit or somewhere else, right? So you can just actually open it up and start viewing that. In a database, you actually have to put data into the database, and that's something you have to do, or you can create it, right? But if you have a shape file or a GeoJSON or some of those files, you actually have to do something to get it in there. And you can use command line tools and things like Ogre to Ogre, or there's a few other in native PostGIS tools to do that. But QGIS has actually also made this a lot easier to import data that you've loaded into QGIS via the user interface. So another step closer to making that a lot easier. And then the final one, of course, is learning SQL. And I think this is a common challenge with everything geospatial, is how much of a specific language or toolkit do I need to know to be really effective? Do I need to learn it all? How much time do I need to spend learning it? What are the things to focus on, or how can I get there as fast as possible? And those are the three big hurdles, right? So getting installed, getting data in, and then actually learning SQL. Now, like I said, both of those first two have some things that have been, improved upon and made easier over the years, as has learning SQL. So you can actually learn SQL. There's a lot of great tutorials. I have a video I put out about this on YouTube about free courses you can use right now to actually study and practice. But the same can't be said as of the spatial toolkit. There are resources out there, but there's no kind of I haven't central resource on how to learn this. That's one big area I think is missing.
Okay. All right, cool. Thank you. I think to summarize, so the pitfalls that you've pointed out is getting SQL installed, getting data in once you've installed that, because that's not an issue itself, right? You can have it, but how do you load up data and start using it? And then learning to be able to write SQL commands and retrieve data the way you want them. So I think it's something that, like you mentioned, some of these areas haven't been touched. There's still a lot to be done in terms of geospatial. I think we're going to touch on this as the conversation goes on. So I've read, somewhere where SQL, Spatial SQL, is dubbed the GIS without GIS. Is this something you agree with? And how is Spatial SQL being done in a GIS software? Because it's like what we talked about so far is that you have to write command, right? You did mention the command line. So is there
Mhm.
any way to do Special SQL in GIS? Is it something that people are really doing and they don't know? Oh, this is Special SQL that I'm doing. Is that something you can talk about?
Yeah, and if we're thinking, GIS, if we equate that to a desktop software, right? Something like a QGIS. That's sort of how, I mean, that's how I learned GIS was using, ArcGIS and eventually QGIS. So, that's how I learned it. And I left school with very little coding experience. So, if we think of GIS as that desktop toolkit, then yes, you can do everything spatial analytics wise within a spatial database that you could with a desktop toolkit. There are still some things like some of the spatial analytics where some of that might be a better fit for things like Python, but more and more that's coming into the spatial SQL place as data gets larger and larger. And when I'm talking about that is, if you're not familiar with the Python spatial analysis library or PySal, a lot of those things are really good for Python, but the data prep work can actually be done in PostGIS and then pulled over into Python. So that's, I think, a very common workflow is people using a database plus Python or a Jupyter notebook. But like I said, a spatial database can connect to your desktop GIS tools. So you can certainly do that and take advantage of that scalability and power, with a desktop tool. And that's what I love about it is you can download QGIS, install PostGIS, and be up and running with a very familiar interface between the two and start using it. And even within QGIS, there's sort of a visual query builder that you can actually use to do that. You can actually click buttons and kind of get a query spit out. So there's all these things that are there to help you kind of tinker around with it and start. Now, making the leap to being fully proficient in writing your own queries, that's the fun part. Because once you know how to do that, you can start to blend data. You feel like you can do anything you want. In a traditional setup, it's kind of, okay, first I need to click here, then I need to create a layer, then I need to click here again, or maybe I'm creating some, very long workflow and like a model builder type tool or something like that. That becomes a lot easier in SQL as you can just start to script that out. So you can actually build that and do what you want in that way. So getting to that level of, fluency takes time, but once you get there, you kind of feel like it's some magic that you've never discovered before. It's just so fast and performant. That's what I really like about it.
Yeah, it's like performing special analytics on steroids.
Yeah, that's a good analogy.
Yeah. So I think yeah, you did mention something about running these queries on QGIS, using a visual query builder. Apart from doing select by attribute, right? People do select by location. Is that anywhere special SQL? Using traditional desktop GIS.
So I mean, yes, there within that interface, you can actually write the SQL, right? So you can open up a panel, you can write SQL and say, select star, from this table where this thing happens. You can do your joins, you can do you can do any of those things with the data that's already in your database. So you're ready to go, and you can actually start using that. So what I like about it is you can write queries in QGIS and then just add it as a layer. So it's not just like, oh, I have this layer in this database and I just add that layer. You can actually create a version of that layer from a query and then put that into your map. So that's where I think it starts to get really powerful, is when you're doing the analytics in the database and then, basically letting the database do the heavy lifting. And when you think about it, the closer that data is to, your data or your querying is to the actual database, and the database is sort of compiled from from C in a very base language. That's going to be far more performant than doing analytics in memory on your computer. So this is more of the kind of the computer science side behind all this, which I do find very interesting. I'm no expert, but the bits that I do understand is, effectively being able to do all that within the context of a database, which is going to be incredibly fast and powerful and is optimized to do that one thing really well, is going to be far more performant. So yeah, you can do all that querying. You can get started with that visual query builder. And then as you build skills, it's just kind of taking bits and pieces from other things you've done and trying them out. So it's kind of that bridge. And I think that bridge is getting better and better for, folks that have come out of or learned a traditional GIS toolkit.
Right. I totally agree. Because it's like you're running the commands on the database itself, so you're closer to home, right? So it runs faster and it's more efficient than doing it like through a connection or anything like that. So let's talk about spatial support for SQL databases, right? For example, we have I think one of the most popular one is PostGIS, right? So what is PostGIS, and what other databases provide special support apart from Postgres, which is supported with PostGIS? Are there any other databases that support spatial queries?
Mm-hmm. The number has just increased rapidly. PostGIS is probably the most prominent and well-known, I think, due to the development community around it. There's a very, very active community and group of people who contribute to it and also use it. It's open source, so anyone can actually download it and use it. And I think it's also a very powerful tool. It probably has the most spatial functions available within it. So that's why PostGIS is sort of grown in popularity. Like you said, it's the spatial extension to PostgreSQL or Postgres, which is a different open source database that was developed by one of the people that is sort of like a godfather of databases from University of California, Berkeley. So he was actually instrumental in building all these databases in the 90s and things that became, I think it's like IBM DB2, which is a database that also has spatial capabilities. Oracle databases have spatial capabilities and have since I think the 90s or the 2000s. And now all the major data warehouses are supporting that as well. So when I talk about a data warehouse, the difference between a data warehouse and a database, in the simplest terms, is that a database can be used for analytics, but is really designed for transactions, right? If you have imagine you have an application, you're filling out a form and that data is getting inserted as new records or something like that. That's what a database is really good for. And coincidentally, it's also very good for analytics. A data warehouse explicitly is for analytics, right? So it's very focus built on that. So it's performant for larger data sets and doing analytical type of queries. So, selecting segments from where or aggregations of data and things like that. But BigQuery, which is Google Cloud's product, Amazon Redshift, which is the AWS product, and Snowflake all support spatial queries. And then there's even more that are coming out, that are supporting that as well. There's Apache Sedona, which is the sort of spatial extension to Spark and the Spark ecosystem. So you can actually do spatial queries and things like that within Apache Sedona. That project's gaining, a lot of popularity for very large data sets. You can also do that with these sort of, distributed query systems, things like Trino and PrestoDB are also supporting, spatial components as well. And the other one I'll mention is SpatialLite. So it's, sort of the extension of SQLite. You can actually use that as well, and that's also open source. So it's a very lightweight download and install compared to Postgres plus PostGIS, but also has spatial functionality, and even MySQL does. So you're going to see it in just about any place you go. Now, how much between all of those is the same is it's hard to determine, but certainly there's you can kind of compare and contrast. But PostGIS is just popular, like I said, for those reasons I listed out earlier.
All right, great. I think that's a very long list there. I probably haven't heard about some of them. Yeah, that's great.
Yeah, it's just growing in popularity, so more and more people are starting to use it, which is cool. It's just grown so much.
Yeah. So I did hear you mention something about cloud, right? So there's a lot of discussion around cloud native geospatial solutions, right? So are there any cloud-based spatial SQL databases in the list you provided? And if so, how do they work different from the one we have to install on the computers?
Yeah, so the three I mentioned are as data warehouses could be considered cloud native, and that's Google BigQuery, Amazon Redshift, and Snowflake. And what they do differently. Basically, a data warehouse, like I said, is meant for analytics, but the storage and the compute processing are separate. So what that means is that you can store data for, very, very cheap, and then use it basically as a query engine to query that data very fast. It also can, parallelize the query. So it can take parts and kind of spread them out and, do them, in parallel instead of just one single strand, sort of operation, which a database would use in most cases. So that parallelization is certainly one. Also things like Spark, I think, those tools I mentioned are also fall under the serverless category, which if you're in cloud computing means you basically rent the server space or the compute power you need for the duration of that operation, and then it shuts down, right? So, you're basically leasing it. It's more like an Uber. You can use what you need during that time compared to owning a car, which that database or service is always on. So, but I think the Spark services certainly fall in that cloud native kind of component. So like an Apache Sedona or something like that. And then more and more those sort of distributed query services I mentioned, like Presto or Trino, are also sort of the clouds are turning those into sort of their own distributed query services that take advantage of serverless and things like that. What's really interesting about those and the data warehouses is that you can just sort of dump your files somewhere, and you don't even need to, like, quote unquote, import them into a database or data warehouse. It's just reading the files from that core location. And then you just it's basically a SQL query engine on top of that to look across multiple files. So that becomes very interesting because it sort of removes that first blocker that I mentioned. And especially when you're working with massive amounts of data, that can be a big advantage.
Right. I think it's really interesting, being able to not just, handle small data set, but being able to handle really large data sets and SQL, for special SQL having the ability to support this. So we talked a lot about special SQL functionalities, what you can do with it, and how you can get it. Well, could you maybe give an example of real world application of special SQL? Maybe it could be in urban or transportation or maybe natural resource management that you have seen, or what you've seen being used in the industry, for example. Because I think people might want to say, okay, fine, I want to learn special SQL, but how can I use it, right? What applications can I apply, special SQL to that's going to help? So could you tell us a little bit about the real world applications of special SQL?
Yeah, absolutely. I mean, there's so many, which is the fun part. I mean, it's anything that you might, do general GIS for, which is great. Some interesting ones that I really like are sort of, doing spatial analytics for urban planning, kind of looking at walkability or building networks, even using PG routing to do routing calculations. This is something that we used recently in a project with Cardo to look at and create a routing network or road network, and say, imagine if this road was closed due to a natural disaster, how long might the detour be? Or if we closed it for construction, how would that isolate specific communities and how long would they have to drive for? So that's a really common one. Enriching your data with, census data or things like that. Another very common one. So let's imagine you have two different geometry types. You have your demographic data at one geometry level and another one at another geographic level. And you have to figure out how many people live within that from the base layer. And you can kind of use a couple different functions to do that. That's another very common a use case for that. Natural resources is very prevalent as well. So managing multiple different layers and updating them as new data becomes available. I've seen that, across multiple sort of, agencies that are global in nature to manage their geospatial data with a spatial SQL powered database. And I think, in the context of, where we are, I was, talking about some use cases that might be really interesting. I think one is I was able to meet someone who came to the Cardo Spatial Data Science Conference in New York City, and he kind of was talking about some of the work that he did. We met up after the conference, but he does sort of election monitoring in some East African countries, and manages and collects data. People in the field actually collect the data and they submit it all, and it goes into a spatial SQL enabled database. So you can query and get reports from the field And that's sort of that transaction-based model where there's lots of data coming in, and it all centralizes in a spatial SQL database. And then from there, you can, do your analytics and your dashboards and everything like that. So, it's sort of really powerful to do all these different pieces. So, anything you can imagine, really, which is, sort of hard to put the bounds on. But I think I've seen it used for just about everything from telecommunications, within government, within, like you said, kind of resource planning, transportation, urban planning, retail, advertisement and marketing. I've seen it used everywhere.
Right. I think that's really interesting. I'm already feeling, really passionate about it already, right? So, you did mention something about special functions, right, that are being used in Spatial SQL. Could you mention some of them? I mean, you mentioned st_intersects. Could you mention some of them, how they're used, and which ones are your favorite? Which one do you seem to use the most in your work?
Yeah, there's, I think, broadly a few different categories. There's a few for, geometry creation, so creating points from other data, or creating a polygon from string, a set of points or things like that. So there's lots of different functions that can do that. Or, if you have a different data type, like a GeoJSON in a file, or, if you store your data as like well-known text or well-known binary, you can turn that into a geometry or geography within your spatial database. There's also, these geometric or geographic transformation functions that you might see. So transforming, let's say, a polygon to a centroid, or a point to a buffer, or anything like that. There's another set of, sort of core functions around that category as well. I think the ones that I use the most are the spatial relationship functions, which is, like you said, st_intersect. So you're basically looking for the relationship between two or more geographies. So if you think of, is this feature next to this feature, does it touch it? Does it overlap it? Does it fully contain it? Does it just intersect? Is it, anything like that? You can kind of determine, from a spatial relationship function. So st_intersect is kind of the go-to with that. I would say it's used the most. But there are other ones that are more specific underneath that as well. You can also do measurements. You can measure, different things like an area or a perimeter or a length. You can create bounding boxes. So there's some measurement ones as well. And then there's kind of like these sort of functions that look at part of a geography, like how many points is a part of that. How many points is a part of a polygon or anything like that. So you can sort of do more manipulation with that. And then there's a few more, that's sort of scratching the surface. There's functions for 3D data. There's a whole set of functions for raster data. So there's lots more within that. I don't have a specific one that I think I use the most. I mean, it certainly intersects or some of the spatial, sort of relationship functions, I think, are the ones I use the most. My favorite one is the one that I've learned recently. I've had to look up for something I didn't know I can do. So I always find that fun, is like, I never knew I could do that, but it's never let me down when I need to find a function of what I need. I need to say, hey, I have a random point and I have a set of lines, maybe railroads. Can I find the shortest distance between the two and find the exact point at which that shortest distance would touch on that line? And you can do it. I was able to find write a query to do that and find that point. And then you can do it over a couple, tens of thousands of points on a map very, very quickly. So, it's always the next thing is kind of, I would say, my favorite at that time.
Well, great. Thank you for sharing that. So there's always a need to improve performance when carrying out special SQL queries, right? And I think that's where the concept of special indices comes in. So what is that? Could you explain what special indices is and how to improve the performance of special queries?
Yeah, there's really two sort of groups of spatial indices or indexes. The first is sort of what you would do as a spatial index on a database, and that's sort of a grouping or indexing, or better yet, a reference system within a database. And there's multiple types within. I'm going to use PostGIS as an example. So there's multiple strategies to do this, about how you index data. So there's and even within a database itself, there's sort of there's multiple types of indexing even within that. So this would be called spatial indexing broadly. You can create a generic index. You can create more specific ones using, there's like the GIST, GIST. So there's a specific type within that, R-tree and lots of others, right? So there's different types you can do, and, can't get into too many of those covering that, but I've even seen newer ones for search algorithms that are using some interesting new methods that people are kind of coming up with to index data even faster. The other one is sort of, what we might, if you're in geospatial, know as a global discrete grid, which is a gridding system that covers the entirety of the globe. And there's a few that have become popular. There's H3, which is originally developed by Uber. There's S2, which was developed by Google, and then there's Quadtree, which was developed by Microsoft as a part of Bing Maps when they created it. And what that does is it basically turns a geometry or a part of a geometry into a string, and that string will represent an area on the Earth. And for H3s, that's a hexagon. For S2s, that's sort of these odd sort of shapes. They're kind of hard to describe. And then for quad bins, that's a square, right? So it represents that square. Now, the advantage of using those, especially for very large data sets, like very, very large numbers of points, is one is around data storage. So within a database, a point, I'll pull the example from Google BigQuery because we recently did an analysis on that. It's basically a point takes up 40 bytes of data, right? Because it's believe it's per vertice 16 bytes plus a base of 24 bytes. So you have 40 bytes of data compared to a string, which is what an H3 is. And it's basically 4 bytes plus the length of the string. So that's 19 bytes. So it's half the data size, right? The other thing is that when you're performing a spatial intersection or join, however you want to call that, doing that operation where you have to basically, if you think of all the steps, first, if I have my target polygon, I'll create a small bounding box around it just to quickly see, okay, what things fall within the bounds of this polygon, and then actually do that overlap for each point to point or things like that for polygon to polygon. That can get to be a very large operation where if you're just joining two strings together to see if they're true or false if they join, that can move much faster. So those spatial relationships can move at an order of magnitude that's much higher. Now, the downside is that it's not entirely accurate when you're filling in a polygon, but it can get very, very close. And we've had good success with that, especially with the extremely large data sets. So,
right. And I think it's nice that we are having all these different technologies to help, support the handling of large data sets, when performing special queries. And I think that's really good. So could you talk us through how SQL supports the integration of different spatial data sources, and also how it allows the integration between spatial data and non-spatial data?
Yeah, basically what's really nice about, for example, PostGIS is that it's a data source in, GDAL or Ogre to Ogre, and any data set you have there, you can basically push into PostGIS. So it'll, GDAL or Ogre to Ogre will handle the transformation for you. So that could be anything from a shapefile to a GeoJSON, KML, you name it, right? You can transform it into that. CSVs, the list goes on, right? There's lots of different data types that you can possibly pull in. So the integration is growing quite a bit in terms of what you can pull in to actually integrate there. So when you talk about integrating the two, your geospatial and non-geospatial data, of course, when you're working with geospatial data, you're going to deal with every other data type under the sun. You already have access to all of those functions and all those things that you can use to transform dates or, clean up your data or, work with string data and, or look through and find, fuzzy matches and so on and so forth. There's just so much there that's really accessible from the non-geospatial data side. So that's where the power really comes in, is if you quickly need to modify some data. GIS tools aren't purpose built to do all the other data cleaning that you might possibly need to do. Plus, as more and more people are adopting databases and data warehouses, your geospatial data is sitting right next to them. So there's no more barrier of, okay, can you change this data, send it over to me in a CSV? I have to join that CSV to some geospatial file I have, and oops, the data's updated, so I don't have to keep doing that again. It's just all happening right in the same place. There's none of that taking place, which I think that's probably the most powerful part of it, is that increase in collaboration.
All right, great. So let's talk a little bit about, because spatial data science is on the rise. I mean, a lot of people are trying to get into that because they need to really analyze some big data sets and all of that. And you did mention the role of SQL in data engineering, right? Spatial data engineering. So how does spatial SQL support analysis of spatial data in the context of machine learning and AI, Geo AI in particular?
Yeah, there's more and more packages being built to do machine learning, within a database. So all the data warehouses that I mentioned have a machine learning component where you can do anything from linear regression to, classification, to more complex types of regressions like a regression tree or a boosted tree model like XGBoost. So that's happening there. And I've seen some extensions like that can do that within a Postgres database as well. So, I think, machine learning really took off because you could do that in a Python environment. Like, it made that sort of science really accessible. You didn't have to know all the statistics and all the math behind it. It was just kind of there. And of course, there's lots to learn just to learn that. But if you're already working in a database setting and you need a pretty, a model just to test some things out, that's right there ready for you to use. So it even removes another step of, okay, I prep my data, now I have to get it into Python and into a pandas data frame or a GeoPandas data frame to do some sort of machine learning function. So that's one advantage. The other one is that data, if it's live and changing, you don't have to move your model anywhere. You can just keep running it in the same place. And the good part, especially about the ones in the data warehouses, these are being developed by Google and AWS and all of that they're, there's really smart folks thinking on and working about that, so I think that's really interesting too. Now, of course, that's, there's potential, issues with that as well, with, one company is kind of controlling it all, but I think they're just making it more accessible and using the open source tools that are already being put out into space. So I think it's not like they're having some proprietary model. They're just using what is open and tested already within a database or a data warehouse setting.
Right. Thank you. So that's it. We've talked about a lot. We talked about the features of Spatial SQL and a lot about how you can get it and where you can access it and different ways that it's being used and why people should use it. But let's just do a little bit of a summary here, right? So why should someone learn Spatial SQL and who should learn it? Right, apart from just learning about who should it, because people might be listening like, okay, my job role, does it require me to learn? Should I learn it? Right. So who really should learn Spatial SQL and why should they get on board to understand how this works and use it in their workflow? Yeah,
the two groups I think that can benefit from it quite a bit, and then there's one sort of generic statement I would say, but I would say anyone managing sort of large amounts of geospatial data, and preparing it or cleaning it or aggregating it or doing anything like that, I think a spatial database is incredibly valuable, right? And you can kind of keep multiple vintages of data up to date. You're not having to sift through multiple files. It can get very efficient to actually do that. And even manipulate or change, geometries and that type of thing. So like I said, if you're using a traditional sort of GIS toolkit, you can still connect to a database and keep that very accessible, and expose that to the other group, which is the analysts. So if you're doing any sort of spatial analytics, I think it's really going to become imperative to have that as a skill. Just more and more as data science is incorporating SQL, and now the general analytics space is also has been using SQL for a long time. I think any GIS analyst that's using that data to join or aggregate or produce maps or anything like that, SQL is just going to be, turn you into kind of a data wizard where you can quickly, join and adjust and aggregate. You can just do so much, and bit by bit, you'll just build that skill set out. I mean, if you think it, you can do it in SQL, right? And it's hard to sometimes translate that thought, how you think through an analysis into SQL. But I mean, for an example, let's say I have a set of locations, maybe they're stores and I want to find the 3 nearest things to those, and then rank them and spit that out as an Excel. So for each location, I have 1, 2, 3, 1, 2, 3, 1, 2, 3, and then pull all the other data with that. You can do that. I mean, there's ways to just, write that into SQL. So, you can kind of ask those questions, and how you translate that into a database language. That's probably the part that takes some work and some learning. But I think those 2 areas are key. And then if your data is getting too big, your maps are getting clunky, they're hard to see, and loading data is painful, or you have too many files, a database is a really good solution. I think just the larger the data gets, the easier it is to go to a database setting. So if you're sitting there with tons of files and folders on your computer or in some other location, or if your data is just, you're pulling it in and eventually it's just like, I can't even load this in my desktop, that's kind of your computer's telling me I'm running out of memory. It's trying to tell you something. So that's another good time to say, a database could do this and I could produce those analytics. And then, how to jump in, there's lots of tools to visualize that data now, from QGIS to many others. We do at Carto, we do that with, the data warehouses and even PostGIS for web purposes, but there's so many different ways you can go with that. So analytics, sort of anyone managing geospatial data. And then if your data is getting too big, I think, that's a good reason to check out Spatial SQL.
Right, I totally agree with that. The kind of question that was thinking about just now, you were talking. You did mention something about data visualization, right? And so how does SQL Spatial SQL support data visualization and cartography, right? Considering the fact that you're not able to see things when you're writing the code, right? So how do you? That sounds like a drawback, but I don't think it's really quite a drawback. But how do you start seeing the things that you're doing in Spatial SQL?
Yeah, the database alone is the database, right? You're going to need some sort of client to, or visualization tool to see that. QGIS is certainly one. PG admin, which is sort of the administrative end of PostGIS, you can also use. It has a very pretty simple geo visualization kind of component within it, as does dbeaver, which is a pretty robust suite of database and data warehouse management tools. You can certainly write queries to PostGIS from GeoPandas, and of course visualize that in a geodata frame, or use any of the visualization toolkits that are provided in the Python ecosystem. I recommend checking out LeafMap, which is basically brings all of those into one place, so you don't have to search and scour the web for all these visualization tools. It's all kind of right there. So you can use any of those, and then web-based. That's what we've been doing at Carto, is to say you can query that data and very quickly visualize that in a map. The other method, of course, is map tiles. So when your data gets large enough, you have to create tiles to efficiently visualize that on the web. And the good news is, PostGIS supports, tiling within it. So it has specific tiling methods to create raster or vector tiles. And then you can, there's open source tools to render those tiles and turn them into a visualization that you can use in any web map that you have, if that be Leaflet or Mapbox, wherever that might be. You can do that. And same thing we did at Carto to do that, is to do that tiling and embed it within the data warehouse. You can do that at that massive analytic scale to create tile sets from millions and billions of records that you might want to. So, you can really scale it up and do all those things there. So those are the visualization methods. I recommend kind of starting with QGIS and maybe PG admin or dbeaver, and going from there to, and grow as you need to, right? But you can still see the map and style the map and create it in the way that you want, but you just need that extra tool to do that.
Right. Thank you for sharing that. I think it's interesting that you also did mention LeafMap, and I think I saw one of the recent posts on LinkedIn where you mentioned LeafMap. I think that tool is really growing in usage, and I think that's interesting to see. So let's talk about how someone can get started with learning SQL, right? Because we've talked a lot about why you should learn it, who should learn it, and the functionalities and powerful abilities of Spatial SQL. So how can someone learn SQL? Are there any resources that you could recommend? Any tutorials that you think? I mean, you did mention at the start of the podcast, but could you reiterate that and so that people can actually, who are interested, could know where to start from and start getting your hands into SQL?
Yeah, so there's a few different places to start. If you want to learn generic SQL, I have a YouTube video that I put together with my favorite resources. And there's quite a few that are both generic SQL, but also for Spatial SQL. There's great resources to actually use and understand SQL. So there's a lot of places you can go to do that. So I definitely check out those resources to learn just SQL, the language, to start with. I put together some tutorials that I really liked. I have a list on my website. It's just Forrest, FORREST.NYC, that has sort of a full list. But kind of like I mentioned, there's no one place to just learn all these things in one spot. But I was sort of approached by Locate Press to actually work on and solve that problem. So I'm working on a book with them, just focused on spatial SQL, primarily focused on the analytics side, to actually use it and learn the language and then walk through real world use cases and get set up and started. So we're hoping to launch that of spring of this year, 2023. So that'll have kind of all of that in one place. So, it's a project I'm working on. I'm pretty excited to get out there because it's just kind of helps to put those things that I see as gaps and kind of start to address them and getting them in one place. So all that said, there's so many resources you can use, and definitely check out the video and the website, because that's where I put all my favorites in kind of one spot to get going.
Yeah, great. Thank you so much. I'm going to add the links to these on the show notes, and it's really interesting and impressive that you're doing that, this project with Locate Press. And I think a lot of people are going to be interested in the book. I think it's going to fill that gap a lot, and thank you for that as well. Thank you to Locate Press as well. Yeah. So let's talk about the future, right? So how do you see the future of spatial SQL and spatial databases evolving in the coming years? And I mean, we're seeing a lot of developments. I mean, we talked about, more tools being added to support spatial SQL. So what do you think is the future, and for example, the potential impacts that you see in the geospatial industry when it comes to spatial SQL and using that to analyze spatial data?
Yeah, I think usually when there's a wave of new technology or something that moves through the general analytics space or the technology space, it usually hits geospatial 3 to 4 years later, right? So data science wave, started in generically in the 2012, 2013, and then, 2015, 16, 17, that started to hit into, the spatial data science. I think after that, SQL really has caught, that wave in, 2015, 16, 17. So I think, we're starting to see that now. And it really caught fire, I think, in 2018, 2019. So that wave is starting to crash now in terms of spatial SQL. So I really think it's going to be more widely used. I think more people will start to use it and want to use it. Just naturally, as data is getting much larger, they'll be able to use it. And I think it will start with, those two use cases, maybe some analytics or spatial joins and things like that at scale. And then moving into some of those more advanced things like doing spatial modeling or machine learning bit by bit, that's going to kind of continue to increase. And then doing that spatial data engineering. If you're, I think one of the most complex parts about geospatial is just managing that data. And if you can join it, that this, of course, is if your job is solely focused on geospatial, I think that will kind of continue to be if you're using more larger data, but especially if you're going into an organization that does a lot of other things besides just geospatial, you can kind of create a good, a niche for yourself to say, hey, I know how to do this. I can work with this data. I know how to do that within the data tools you're already using, be it a database or a data warehouse. So that gives you a really good edge to, kind of focus in on. And I think that data engineering wave is another one that's going to start to crash into the geospatial space here, soon. So I think more and more roles will start to use spatial SQL. I think it will, improve the speed at which analytics are performed. I think it's becoming far easier to get started. Like I said, some of those hurdles that I mentioned at the beginning are certainly, really starting to become a lot easier. So I think it's just going to become more and more a lingua franca of geospatial. And then most importantly, improve collaboration with people who are not using geospatial data. So those barriers that might have existed before are just slowly starting to go away.
Oh, wow. Thank you so much. I think a lot of us are actually looking forward to, this great future. And if you're listening and you think that you want to be a part of this, I think it's about time you start learning Spatial SQL and start getting used to it. So how can someone get in touch with you if they want to maybe have a more conversation about stuff? How can they reach out to you?
Yeah, the best way is LinkedIn. I try to share stuff on a pretty regular basis there. So if you just search my name, Matt Forrest, on LinkedIn, you can find me there. I'll send a link as well, so you can grab that. My website, like I mentioned, you can reach me there. But those are the two places I do it the most. I've also been posting some videos on YouTube. So I try to do that. It's a little bit more work to edit a video, but I found it to be pretty fun and engaging as well. So those are the three big places. And then, I all my stuff through Cardo. You can check us out at cardo.com. We post a lot of technical tutorials that aren't just focused on our product. We rely so much on Spatial SQL that a lot of the tutorials we put out there are just on Spatial SQL. So you can check those out too. LinkedIn is probably the best way to get a hold of me.
All right, cool. Thank you. I'll surely add links so listeners could look at it. Thank you so much. It was great having this conversation with you, Matt. Really appreciate your time.
Yeah, thank you, and thank you for having me.